Hello, and welcome to my presentation on nutrition research. In this presentation, I will be explaining two major research designs, prospective cohort studies and randomized control trials. I'll also be discussing how relative risk and p-values are used to interpret findings in these studies. First, we're going to speak about prospective cohort studies. A prospective cohort study is an observation research design that follows a group of individuals over time. These individuals are similar in many ways, but differ in a particular exposure. In this type of study, participants are grouped based on their exposure status. Researchers follow them over time, and outcomes are recorded as they occur. In simple terms, we start off with an exposure, and then watch forward in time to see who develops the hypothetical outcome. Prospective cohort studies have several important strengths. Firstly, they allow researchers to study multiple outcomes related to one single exposure. They are useful for studying rare exposures. And thirdly, because exposure is measured before the outcome occurs, they provide clear temporality and allow for direct risk measurement. However, there are also limitations to this research study design. Confounding factors are a major concern because they involve other factors that may influence the outcome of the research study. This makes it difficult to establish causation. These studies are also time-consuming since participants must be followed for many years. And finally, they can be expensive due to long follow-up periods and large sample sizes. Next, we're going to talk about randomized control trials. A randomized control trial is an experimental study in which participants are randomly assigned to either a treatment group or a control group, and this is to test the effects of a specific treatment. In RCTs, assignment is by chance. There is always a comparison group. Researchers actively apply the treatment, and outcomes are measured going forward. Randomization helps balance both known and unknown confounders between groups, making RCTs the strongest design for determining causality. RCTs as well have several key strengths. These include the fact that they provide the strongest evidence for causality due to the randomization of the participants, which minimizes confounding factors. The concept of blinding can also be used in the research study. It can either be single, double, or triple blinding. This reduces placebo effects and measurement bias. Overall, RCTs offer a high level of internal validity. Despite their strengths, RCTs have limitations as well. One of the limitations being their limited generalizability due to the strict study conditions, which may not always reflect real-world populations. They can be expensive and complex to conduct, and in addition, ethical constraints sometimes prevent researchers from randomly assigning specific exposures. Between the two study designs, there are several important differences. Prospective cohort studies are observational and involve naturally occurring exposures, while RCTs are experimental and involve random assignment. Because of this, cohort studies have weaker ability to infer causality and are more prone to confounding factors, whereas RCTs, on the other hand, provide stronger causal evidence. As much as they are different in their designs, they also share some similarities. Both of these studies are prospective, meaning that they follow participants forward in time. Both measure incidence and both compare outcomes based on exposure status. In nutrition research, when researchers are trying to interpret their study results, they use the concept called the p-value. The p-value is used to test whether an observed association or effect could be due to chance. A small p-value, typically less than 0.05, suggests that the result is unlikely due to random variation. However, it's very important to remember that the p-value does not prove causality on its own. In RCTs, the p-value tests whether the difference between the intervention and control groups is likely due to chance. In prospective cohort studies, the p-value tests whether the association between exposure and outcome could be due to chance. But it's very important to remember that confounding factors may still exist in these studies. Another way that researchers interpret study results is by using relative risk. Relative risk is a measure that compares the risk of an outcome in an exposed or treatment group to the risk of an outcome in an unexposed or control group. It is calculated as risk in the exposed group divided by risk in the unexposed group. Our relative risks are measured in terms of the value 1. So a relative risk of 1 means that there's no difference in risk. Relative risk value greater than 1 indicates higher risk, and a relative risk value less than 1 indicates a protective effect of the treatment. For example, if 20% of active children develop obesity compared to 10% of non-active children, the relative risk is 2. This means the active children have twice the risk of developing obesity. In summary, prospective cohort studies and randomized control trials are both important tools in nutrition research. Cohort studies are useful for observing natural exposure over time, but they are more vulnerable to confounding factors. RCTs, on the other hand, provide the strongest evidence for causality through randomization, but they may have practical and ethical limitations. Finally, researchers use relative risk and p-values to interpret whether associations are meaningful and whether they may be due to chance.